One. So here we go. Let's see what you guys remember. What's a mole?
The goal.
A unit of measurement?
What kind of unit of measurement?
It's used for really small things. It's used to measure really small.
It's a metric quantity, right? It's a metric quantity showing the amount of carbon-12, right? This is all based on carbon. You guys remember doing this freshman year?
Yeah.
The amount of carbon-12 particles in 12 grams of carbon, which we all know is 6.02 times 10 to the 23rd. Is that something you have to know on the test? No. Oh, shoot. What the word mole represents a specific number. Give at least one common example of a word that represents a specific number. Who can give me a different word?
Pi.
Dozen.
Pi. What else? Dozen. What else?
Baker's dozen.
Okay. Baker's dozen.
Aubrey.
What else? A score. What is a score? 4 score? Yeah. You got it. So any of those examples would be great.
12 grams.
Yeah, 12 grams of carbon. It's the amount of particles, the amount of carbon-12 particles in 12 grams of carbon-12. What's the formula of mass of a substance? What would you guys say that is? The formula mass. What is the formula mass of magnesium?
Is it the molar mass?
What?
It's not the
Yeah, it's the same as the molar mass, right?
Oh. I was like,
So magnesium is
what is the molar mass
24.305.
of a substance on
It's the same thing, right? The molar mass is just the mass in 1 mole, which is still the same exact thing. 24.305 for magnesium. So, quick, get out a calculator. For the mass of calcium phosphate, just to make sure you guys know how to do this. We are assuming we know nothing.
What's the charge on phosphate?
Charge doesn't matter for the mass.
No, I need a formula.
Oh, Ca3,
I know CA3.
PO4, parentheses 2.
Yeah.
Yep.
Because phosphate has-
Far away. I can hear that table. Anyway,
Yeah, I can't read that. I'm chronic. I'm
I'm like one of those native mole rats. So is the formula not excluding the?
The formula mass and the molar mass are the same thing, except for the molar mass is per mole.
I want the way that we have 8. I got 310.174.
Everyone else have the same thing?
310.16.
It depends how you round.
Your reaction directly after that to just rub your face made me.
No, I just feel like I have like still a slight headache from the eclipse yesterday. Like I think there's a couple times when like the full sun hit my eyes. Anyone else have
Hit
that?
my eyes. Well,
Yeah.
I would like.
I just like winked it away.
Oh,
I just buttered
you're
it
still
out.
Start
built
looking
different.
at it and then take off your glasses for like a second.
I know. Like those even little pieces, like I think
I
just
have a headache.
yeah.
I have a headache. I can't do it anymore.
Do we have confirmation of the 310?
Yeah.
310 point what? So 310 point what? What are the units technically? Anyone remember what the units are? It's technically just like unit mass.
That's dumb.
Now, what's the molar mass? It's 310.07 grams per mole. It's the same thing.
Bro.
So these are like unit masses, grams per mole, same thing. And we know that 1 mole is 22.4 liters to 6.02 particles. Flip the page. Flip the page. All right. What?
I said I do not feel like I.
Well, the U, we don't really talk about the U. It's just like units of mass, but. So 1 mole of mass is the same as what? We just talked about it.
102 times 10 to the 23rd.
Okay, so we'll do that. That's 6.022 times 10 to the 23rd particles. What else is it the same as?
22.4 liters.
22.4 liters at STP. Also the same as what we just did, which is the molar mass. So those are the 3 things you will have to be able to convert to. So What would the conversion factor be to go from number of particles to the number of moles? Well, we know that 1 mole of stuff would be over 6.022 times 10 to the 23rd particles. We were in Mount Vernon over the weekend, my wife and I, for her birthday little getaway. Have you guys ever been to the park in Mount Vernon that has like a tower that you can climb up? And there's like all these like different levels of like grass, like, you would know what I'm talking about. You haven't? Okay. Well, never mind.
Mr. Ho, we get our caps and gowns this Friday.
Oh my gosh.
Thanks.
Wow.
Why are
Wow.
you saying no? Because like literally everyone's gonna be gone.
Yeah.
thanks for them
Yeah,
seeing
that's
your
the
friends.
point.
The last 2 weeks it'll be me, Emily, Jawa, and Megan.
Oh.
Just hanging out.
It'll be everyone on the right side of the room.
Oh yeah, was that on purpose?
No.
Did you say segregated?
You are segregated. Seniors, juniors.
I'm the middle.
All right, this conversion factor, 1 mole of H2O would be over 18.015 grams of H2O. And that could, either one of these could be flipped, right? It doesn't matter which one's on the top, which one's on the bottom. Okay. What would be the number of phosphorus atoms in 2.34 grams of calcium phosphate? Do it.
Okay, cool.
This was like from test, the first test we did a problem just like this.
Oh, it's the same thing, right? Calcium phosphate.
You actually have to do some stoic here. You already have the mass.
Oh, I know how to do this. Maybe.
Thanks for sharing with the class, Jack.
Oh, such a face.
Spicy there, Jack.
Uncooked.
I could have told you that. Oh,
Wow.
sorry. I'm very
Some
I
sassy.
thought you had no energy today.
I don't.
I see your Niagara Falls shirt. Can you imagine being at Niagara Falls and seeing it?
Oh.
Because that was totality.
This is my brother's shirt. As soon as he left the house this morning, I went and it wasn't bad. So.
Being at the Guardians game, that would have been awesome.
What's the story?
What do you mean, what's the stoic
No, I know what it is. I
Yeah,
just want to make sure I did it right.
Stuff.
Okay, so you know what it is, but you just
Well,
want
I
to make
just
sure
wanna
you
make sure I
did
have
it
it
right, so you don't know what it is.
I'm stopping here because I want you guys to finish from here on out.
You want to get 0.468.
Jolly, we don't need grams.
Number of. Oh, are you kidding me?
Did you read that?
You go to. You have to be rizzing me right now.
Yeah.
That was wild. He said 4.6 phosphorus atoms and 2.34 grams of calcium phosphate.
We should give me a red calculator. Maybe I'm not.
I just have what's in the green tub.
I need to charge my calculator. Real bad.
Mine's been at like 50% for quarters.
I got 9.09 times 10 to the 21st.
Yeah, I got that.
After this step, what is your next step?
Moles calcium phosphate.
For every 1 mole of Ca3, thank you, PO4 parentheses 2, there are 2 moles of P atoms. So don't forget, when you're doing atoms, you have to consider your subscripts. And then every 1 mole of P atoms has the 6.02 times 10 to the 23rd. So what'd you get?
9.09 times 10 to
9.09 times 10 to
the 21st.
the 21st atoms of P. Was your brother's recital this weekend? How was it?
Good.
Good? Were there any special guests?
He had a quintet.
Cool. So it was fun. Nice. Flip the page. Okay.
What was it?
Oh.
9.09 times 10 to the
Oh, I
21st.
remember this. This is the one that got me.
Atoms of P. Okay. Calculate the element abundance.
0.09 times 10 to the 21st.
The atomic mass, if the naturally occurring isotopes are here. I've set this up for you pretty nice. Right? Because it's mass times abundance plus mass times abundance plus mass times abundance plus mass times abundance.
It's like in statistics.
So this times this, and remember, this is percent. So what do you have to do to the decimal? Move it 2 to the left. So 1, 2, 1, 2, 1, 2, 1, 2. Unless your calculator can do percents.
You want to figure out all of those decimals.
You don't have to show your work. I don't do solve it if you know. As long as you know what you're doing.
It says show your work.
I know. I don't care if you show your work, unless you want to show it. I feel like if you put times, 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 and then add them up, something like that, that would be showing our work. Spring came back this week.
Spring did come back.
Any games today? Today's the best weather day of the week. It's gonna be rainy, but still warm the rest of the week.
Anyone get 51.1?
Sweet. You guys should win that. Okay.
We played Westlake on
WA.
Saturday.
And we beat them 19-3, and then JV tied. So we good.
Okay.
In the last one, she literally, after she missed the free position, she literally screamed the F word through her stick, so she should have gotten a yellow card. But she didn't, and then she scored.
She said fine, right?
Right.
Yeah.
For sure.
I was thinking about your dad and all of his roommates like during totality. I was like, that's so cool that they got to see that. Oh yeah.
Some of them are still here, and I'm like, the trip is over.
Well, they're gonna hang out now.
Yeah. Like, my dad has to go to work.
Where do they all fit in your house?
I don't know.
Just everywhere?
My brother and I both slept on the floor of our parents' room. And we put 3 blow-up beds in my room.
Yeah.
We put 2 blow-up, we were using like elderly blow-up beds. And then we had like one, like we had like one like guest bedroom. And then we put 2 blow-up beds on my brother's floor. And then we had a bed in the basement.
Sweet. I have an invitation to one of my friends from college who lives in Florida for 2045. So, and the eclipse is going to be in Australia in like 4 years.
Mr. Knight is going to be.
But we had to wait 20 years for the next one.
What? In the United States. And the one in Australia is actually like 5 minutes of totality. I was like, in 4 years, my daughters would be 11 and 9. That's a good age to go overseas. And I've always wanted to go to Australia or New Zealand. But what'd you guys get? 51.996. Sure, something like that. Grams. That times that, plus that times that. The main thing is don't forget to take it out of percent when you're multiplying. Okay, mass spectrum of an element. For the data given, create a mass spectrum and determine the average atomic mass of zinc. Do you guys remember doing these little graphs? So, zinc 64. So here'd be zinc 64. It's going to go up to something like that, right? Zinc 66 is going to go up to something like that. Zinc 67 is 4%. It's like that. Zinc 68 is like 18%, something like that. And then zinc 70 is like that. Yes?
There have never been less straight lines.
I mean, my lines are decent.
I'm talking about mine. I'm not talking about yours.
And then if you were given this graph, right? If you were given this graph, you could approximately calculate these numbers, right? Yes?
I think so. It might take me like back and I have to like.
You would know that it's going to be something probably between 64 and 66. Yes? Because these are kind of like outliers.
It's 65.39.
Yep. It's 65.39 if you do all that work again. 65.39 grams. Okay, flip the page. We're cranking.
No purpose behind it.
There's no good place to staple these, just to let you guys know.
Yeah.
Okay, circle the word to complete the sentence. I know. When I was running these through the copier, it's like, I don't know. Wouldn't ideally the stapler be like in the top left?
Yeah.
Yeah, I need to figure out how to do that. Next one. Empirical formulas represent the lowest or highest ratio. Lowest ratio of atoms in a substance. Substances can share the same empirical or molecular? Empirical, but have a different molecular formula.
CH4 and C2H8.
Yep. Analysis of 37.4 grams of an unknown substance. Chani boy. Oh, Chani boy.
Oh, no, it's back. It's back. It's back.
22.814 grams of carbon, 5.76 hydrogen, 8 grams of nitrogen. What's the percent composition? The empirical formula is compound. Take a second and do it.
It's back. No.
Bruh.
It's back. I remember how to do this.
This actually isn't a Chani boy, but
Oh, yeah, the Chani.
the Chani boy is where you had like 2 different
CX,
compounds
Y.
and you had to subtract to get, yeah.
Oh, no, not the Chani boys. But not the percent composition, too. Oh, Aubrey, I love your background. No, it's not.
I would get the empirical formula and then get the percent composition from that, obviously. I'm gonna start my work now.
How much do you want us to carry?
I'll figure out remember after this.
I do not remember.
I don't remember either.
So,
I added them all together and it's higher than 37.4, so I'm
all right, I'll show you guys.
I do remember how, but I'm not happy.
All right, so I'm gonna take 22.81 grams of carbon divided by 37.40 grams times 100. What do you get for percent carbon?
61.
What? Let's do 1 after the decimal.
Aren't you supposed to do like
We get to get percents first, and then if the percents add up to 100, we assume the percents become grams. Right?
You said they should do the empirical formula first.
I forgot. I usually do the percents first.
You get 8
Wait, are we
hydrogen,
finding
nitrogen.
oxygen?
I usually do the percents first. What?
No, we don't know if this is oxygen.
We have carbon, hydrogen, and nitrogen. There's no oxygen.
Or just 0.60. 0.61.
0.61 what? Is it 61%?
61%, yeah.
Okay, 61% what? Carbon.
Oh, shoot, I'm cooked. Wait, that's not
Then I'm going to take my 5.7596 grams of hydrogen divided by total 37.40 grams. What do you get for that?
I did the empirical formula.
15.4%.
If you got the right thing. What'd you get?
15.4%.
That's not 50%.
No, 15.
Oh, 15.4% H.
Did you say that?
Do I need to do another calculation at this point? No.
Adds up to 100.
Subtract from 100. So 61 plus 15.4 is 76.4. So that means that oxygen has to be 22.6%.
Oxygen. Nitrogen.
Nitrogen, my bad.
You scared me.
Nitrogen is 22.6. So now all of these add up to 100. So those become grams. So I'm going to take my 61 grams of carbon times, carbon is still 12.011, 12.011 grams of carbon in 1 mole of carbon. Then I'm going to take my 15.4 grams of H times 1.008 grams of H in 1 mole of H and get my moles of hydrogen. And I'm going to take my 22.6 grams of nitrogen times 14.007. 14.007 grams of nitrogen in 1 mole of nitrogen. So I'm going to get moles for all of those.
And that's then your.
So that's not the answer yet. So what'd you get for moles of carbon? What?
What? I'm at 1.9. I did it like first. I went from 22.814 grams of carbon and then
Oh.
straight to moles.
Yeah, I don't think that's gonna. I don't think your way is gonna work.
That's 12.0.
We'll see. We'll see. What'd you get for moles of carbon? 5 what?
0.1.
5.1 what? Just 5.1?
Just,
I don't remember.
5.1 moles.
Moles. Okay.
Yeah.
Okay, what'd you get for H?
15.3.
15.3 moles of H. And what'd you get for moles of N?
14.
I'm not sure if your way's gonna work. Because you didn't go off of percents.
Like 1.61.
1.61 what? Moles of N. Now what do we do?
Take the lowest value.
Divide by the smallest.
Yeah, to get your ratio.
So divide by 1.61, divide by 1.61, divide by 1.61. So nitrogen is 1.
No, it does work. It does work.
One.
It worked? Okay.
It does work.
Make it home.
What'd you get for hydrogen?
3.
What? 15.3 divided by 1.61 is not 3.
Wait.
You're gonna
Sorry, I
use
had
carbon.
5.1.
9? What about carbon?
3.
About 3.
3. So my empirical formula is C3H9N.
It did work.
Good. Now, there's a couple ways you can do it.
Okay, that makes sense. I remember that.
And then, remember how I could like give you like a molar mass?
Yeah.
And then you'd rough come up with the mass of this and then unreduce it
Yeah.
to get the molecular formula. I'm not sure if we're going to do that, but that's something you could do. Like, let's just do that for funsies.
I don't know what you learned.
Yeah, where?
Go on the bottom.
If the molar mass of the substance was 118, so if the molar mass was 118, what would the molecular formula be?
Oh, I got it.
I think I did that right in my head. Some quick math.
What's the question again?
If the molar mass is 118, what's the molecular formula? So molecular formula is the unreduced empirical formula.
118.
Yeah.
Should be C6H18
That's what I had. So if you remember how to do these, what's 3 times 12? 36 plus 9. Because 9 times 1, 45. Plus 14.
Or sorry, plus 14.
Yeah. 59. And 59 times what will give me 118? 2. So my molecular formula is all of these times 2. So it'd be C6, H18, N2. Okay. Different types of substances are made up of different type of particles. For each of the following, this is an example of, is this an example of a formula unit or a molecule? Draw an example of a particle diagram of the representative particle. So, an ionic compound, is this a formula unit or a molecule?
It's a formula unit.
Why? You're right.
Oh, right. Okay, because the percent composition by mass of a compound always stays the same. Is that?
Well, an ionic compound is also going to be opposite charged particles, right?
Oh,
Yes?
that way.
So there's opposite charged particles because you have to have, you have to have a positive side and a negative side. And this is usually a metal plus a what? Plus a non-metal. What would be an example of an ionic compound? NaCl. NaCl.
What's after charge?
Formula unit, oppositely charged particles. But a covalent compound is technically going to be more of a molecule. And like the difference between formula unit and molecule isn't super important, but why? Well, these are all the same charge, right? So what would be an example of a covalent compound? C, H, 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 right? Methane. So this is more of a molecule, that is more of a formula unit.
Wouldn't it also be because of diatomic elements too?
Same thing, yep, you got it. A single drop of water contains 3.34 to the 21st atoms of hydrogen. How many oxygen atoms are in the sample? Is that stoic? Yeah, because I would do 3.34 times 10 to the 21st atoms of H times.
You don't even need to get it to me.
I know, but still, we're going to do it. There is 2 atoms of H for every 1 mole of what?
1 mole. Oh, 1 mole.
H2O, right? And every 1 mole of H2O has 1 atom of O. Yes? So it's essentially this number what? Divided by 2. So what do you get? Yep. 1.67 times 10 to the 21st atoms of oxygen. You also could have figured out that water and oxygen are just a 2-to-1 ratio. So you could have just divided that by 2. But I showed the stoic. It's so funny this time of the year, like biology, like they're crunch time because their test is coming up. So it's like no funny business during biology. But if you listen to chemistry, there's funny business. So, because there's no test in chemistry. Okay, flip it. We're moving. I can.
So stressed about the Gov State test.
You have to take the Gov State test?
Yes.
I
Why?
get all those things off.
Oh, because you're a junior.
Oh, yeah.
Well,
Yeah, I'm pretty sure you're going to pass that.
Tyler is gonna hang out.
I got like 10 out of the max.
3 days for the week after, we have 2 free days, but there's a day in the middle.
So it's like for school.
They're probably well deserved.
When do you guys think you're going to get your schedules for next year? I still don't technically know what I'm teaching, so
I will.
I'm guessing AP Chem.
Probably.
I'm guessing some physical science.
AP Chem is like the one AP science class that's never going to be in danger of not running.
I mean, you never know. I know that 24 people signed up for next year, so.
Is that more or less than
aren't they doing it in one class though?
Well, last year we ended up having like 27 or 28, and safe lab numbers is 24, so you have to split it. That's why we had 2 small classes this year.
That's actually so good. I'm glad I went to the class.
I like
I've enjoyed the smaller classes. It's been twice the work for me, but I'll do it for you guys. Anything for you guys.
It just means double the fun.
Double the fun? Yes.
We're the better class.
Next year's AP Chem's gonna be.
Next year's AP Chem is a lot of juniors. Like, there's a lot of juniors who had me as a freshman who are like, I want to take AP Chem as a junior.
That's,
So-
yeah, I
And
can't
last year?
confirm.
Yeah.
That's what I did.
Glad I did.
I'm so glad I'm taking Chem.
I also think like it's nice to do like chemistry, which is what I told all of you. Like, then you don't forget it.
I don't think I ever learned any of this stuff.
Didn't you have freshman year COVID though?
Yeah.
It was COVID.
Yeah.
Yeah, it was kind of.
Yeah.
Never.
All I remember is we did the rockets.
Yeah, that's
Yeah.
all I remember too.
Bro, we went and sat outside.
Mr. Knight and I basically just did labs the whole second semester. Yeah. All right, flip. Are we good? Flip it. Particulate level diagrams.
These are gonna be on the AP exams. So.
Oh yeah, you will draw one of these most likely. Not one of these, but some kind of. How would you draw 3 units of a diatomic element?
Sets of 2 circles really close to.
Yeah, that's what I would do. 1, 2, and then 1, 2, and then 1, 2. What about a compound?
Different sized.
You would have to have different sizes. So if we draw like water, different things too, right?
Is water a compound?
Water's the compound.
I don't know why I asked.
So you have to show something that there's 2 different elements connected, right? A compound and a monatomic element. Okay.
That means 3 compound and 3 monatomic elements.
Well, something like this, right? I'm so sorry. That's a compound. Agreed? That's 3 pieces of a compound and 3 single elements floating. Okay. Finish out 4 or 5. And then do your pure substances and your mixtures. Here it
You
goes.
said they were locked in?
Well, it's the last like 10 minutes now, so.
I just me.
Hi. Did your boxes get delivered?
Yes, thank you.
Excellent.
We have no Weybos.
Oh. A diatomic and a monatomic element. 1, 2. 1, 2. 1, 2. 1, 2, 3. A diatomic and a compound. 1, 2. 1, 2. 1, 2.
I love your eyes.
You guys draw something like that? The beakers that contain a pure substance. So, if you remember a pure substance, how do we know? How have I always taught a pure substance? You can write a formula. Right? Can someone grab that door? Thank you.
The diatomic element.
So, pure substance is A. Whoops. A.
B.
B.
That's it.
Wait, why are we doing A and B?
1 and 2.
1, 2. 1, 2. Can I write a formula for this, or this? No. So my mixtures are 3, 4, 5. So I would say a pure substance is something that has the same properties, right? Same chemical formula. You can write a formula for it. Got some? Excellent. Sorry. Flip the page. This is gonna be close. Gonna be close. Ooh.
Oh.
Whoa!
Oh.
Stop.
Electron configurations.
Okay.
No, these I can walk in.
Okay. Do it then.
Oh. Okay.
1 and 2. 2 S.
Oh.
2 P6.
Not out loud. Not out loud.
We'll come back. Bro, it's easy, bro. What do you mean?
Guys, check this out. Look what this is over here.
Stop.
Coulomb's law.
Wait, you remember during CP Chem where I had to have this thing where I figured out?
I remember a lot of things.
That's 2.
Hey, Megan, this is how things. Hey, Megan,
Thanks for rubbing it.
I carried it.
This was a Miller mass. Hey, Megan, how do you calculate this? Megan, what's the charge? Megan, what's the charge?
Oh, I just wrote it. I was reading.
I think Asher.
Easy. Simplest thing of my life.
Okay.
You lost your door. Okay.
Oh, you have to put the
There we go.
Yeah, Brady, I did the same.
You actually technically don't have to write the numbers in the brackets, but I always do because it helps me keep track of my electrons and make sure that they're the same.
Wait, no, I was right.
Okay, Megan, this is a chart. Megan, how do you do that?
Oh, I love CP Chem.
All right,
Can you check my answer?
carbon. Shh. How many protons does carbon have?
6.
6 protons. How many neutrons does carbon have?
Also 6.
6 neutrons. How many electrons would go in the first level?
Oh, for 2.
Okay, now pause. So that's my 1s2. We're going to do a very technical drawing here. We're not going to do a freshman level drawing here. So how many are going to go in the second level? 1s2. What's going to go in my second level?
Oh.
2s2.
Oh no.
Right? If we're doing super technical. And then how many would technically go in the third level? 2. So if I'm doing a super technical drawing, the 2882, right? That's freshman level, right? If we're doing carbon, it's 1s2, 2s2, 2p what? 2. So 1 level, 1 level, 1
The
level.
P ones look different though because they're like,
Yeah, but we're not going to draw. We're not going to draw that.
Can you draw a key order?
How many energy levels are found in a chlorine atom?
What?
It's 3.
3. How do I know that? Well, I've got my 1s2s, right? I have my 2s2s and my 2p's. That's still 1 level.
Oh.
Yes. And then I have my 3s2s and some 3p's.
The coefficient is the energy level.
Correct. So there's 3. Circle the correct word. Each electron in the atom is the same or different ionization energy. Different. Match the correct term. Electrons in an atom are of 2 types. The inner electrons are also called the core, and the outer electrons are the valence. Remember core charge? Core electrons have a higher. Why? Guess what the next page is?
Sadness.
Trends.
Right.
It's trends. Here's what I think I'm going to do. So I think we'll end here. We'll end here.